Good evening, everyone. This is Dr. Polaiah, working as a professor in the Department of CSC Data Science, IARE, Hyderabad. It's a very glad to see you all once again through this video class. Coming to the for today topic is, as we are in a continuation from our subject, that is image processing and analysis. So as for our IARE curriculum, we are supposed to be understand the one of the topic from that subject is intensity transformation functions. Simply we say intensity transformations. Okay. So intensity transformation, how can you are right now can be concentrate towards to be use this under the concept of image analysis. Okay. So let us we go to have that type of image where this topic particularly we can going to see for especially in our syllabus, that is as per our syllabus. So we are going to see this topic is from the one of the concept, that is how can you or may concentrate the list of from the list of topics where we can have one to another are the list out here. Number one is basic intensity transformation and the spatial functions are. So we covered is all the topics. Number one is intensity transformation functions, and number two is histogram process, and number three smoothing and sharpening, number four smoothing, sharpening, spatial filters, and next one is homographic filter and noise models. And last one is constrained and unconstrained restoration models. Okay, so these all will be going to be covered under the enhancement as well as restoration model. Okay, so with this, what I wanted to call here is this is completely called discussion is from the this agenda only. So that is that what is the agenda for today? Our video discussion is number one topic introduction, number two is course outcomes mapped with your module. Okay, so as for our model syllabus, we are going to discuss today is intensity transformation functions. Once we have the knowledge about this intensity transformation functions, immediately we are going to have the list of applications of image processing. That means where we can use this intensity transformation functions, particularly in image processing Sigma applications. So that means you are supposed to be understand for fact information about this concept is we have to choose which application. That is also important here. Next, coming to the important one is the topic learning outcome also we need to be concentrate. That is, if suppose you learn your today topic, that is intensity transformation functions. So if you name that topic which we are going to be learned from this video, so that means this video help us to understand the basic concepts of intensity transformation functions of the various components, nothing but elements. Okay, so that means you are supposed to be going to gain the knowledge regarding the concept in digital imaging systems. Okay, so this concept which is right now we are going to be have the intensity transformation function. So based on this digital image system, being it is a system, the system is 100% process certain applications. So we need to concentrate how that application can be concentrated and processed in digital imaging system is depends upon one of the components of the concept. That is, you are going to be connected to this system. Okay. Next, this concept which we are going to be understand while we are discussing same concept in terms of proof of the concept is nothing but summarize the concept of fields digital imaging system. So your summarize your concept which you are understood had to be summarize depends upon the your digital imaging system application only. So what will be that one? We're going to see that with the coming slides. Okay. So in coming slides, as per our agenda, we have to introduce the topic. What is our topic? What is our topic? So the topic is intensive transformations. So here the introduction of this is nothing but you are going to be introduced this topic, nothing but you are going to be understand in terms of domain knowledge, that is the spatial domain process. What do you mean spatial domain process in terms of transformation functions? So you are going to be understand where your image, which is a two-dimensional image, 2D. How a image is 2D? Because it coincides in terms of spatial domain. What is your spatial domain? Is y axis one of the domain value. We are going to be concentrate with respect to x. So your 2D image is here. Your 2D image is here. Help us to define this one in terms of f of x comma y. So this f of x comma y is the image in terms of spatial domain. In terms of spatial domain, spatial aspect. We can say simply, it is a Cartesian coordinates which help us in terms of the coordinates of x value with respect to y. How can it be changes in your images? So that x and y coordinates which help us towards to define certain process of values which changes from with respect to x, y will be changes. Once x is changes, y also will be changes, like that. So here we are going to understand that f of x comma is your 2D objective function, that is f of x comma y. It's a function. It's one of the objective function. What is this objective function is here? You wanted to concentrate the intensity pixels transformation within the 2D images. Okay. So that 2D images values are various means in terms of intensity of the pixel values variation only. So that variation of the values, how can you see the visibly in the sense in terms of your objective function, that is f of x comma y only. So your f of x comma y, now you need to concentrate in terms of transformation, So you are transforming of your f of x comma y to the other function, that is g of x comma y. Whereas g of x comma y is your output of the image. What do you mean to output of the image? The output of the image is here in terms of transformation process happened image, that is called g of x comma y. How we may be transformed? What does it mean that t means here? T means is here is operator on f of x comma y. This is f of x comma y over the neighborhood of the point x comma y values. So that means you are going to understand this completely information, which is right now transform of f of x comma y is nothing but g of x comma y. I hope you got my point. Intensity transformation is nothing but your intensity of the pixel values are compared or transformed one another only in terms of neighborhood of the point x comma y. So that means if you take your image, in this image x and y of the pixel, here one pixel, here another pixel, one another pixel will be compared. What is the use of comparison? What is your expected output of the image? How can you understand that output of the image is g of x comma y? It was transformed from f of x comma y. How can we understand that? Yes, we understand with the coming slide is here. We are going to be understand that transformation not be done in a simple manner. We done that with the help of three broad intensity transformation functions. What are those three types of functions used in image processing, especially for the intensity transformation purpose here? Or the number one, linear intensity transformation function. Number 2, logarithmic intensity transformation function. Number 3 is power law transformation function. How these three are, how can we going to be connected together? How can we going to be connected together? We are going to be connect one to another with the help of simple characteristics of the information. Let us you take the y-axis is input intensity levels of a particular image value. Image levels. Okay, image. It is image only. Image. Okay, that levels of the image which we are going to represent in terms of small r. Next, this r now we are going to be connected with small s. What is s? S is nothing but output intensity levels of the s. So here it is completely called f of x comma y, whereas here we are completely called g of x comma y. So that means these all three types of functions are transforming your intensity of the pixel balance into from f of x comma y, that is your objective, towards to g of x comma y. F of x comma y is your objective function, and now we are concentrating from there to go for g of x comma y, nothing but which is we are going to be understand from these characteristics. You see, one of the characteristics value is exponentially increase. What do you mean exponential increases? It is when we are going to be connected your two values of f of x comma y, g of x comma y exponentially values. That is, inverse logarithm of exponential values will be vary. There are simple mathematical formulas are be there for each function. Let we going to see in coming slide. Okay, but point is here, these characteristics, how it may be vary one to another. The relationship of r and s, how it may vary. F of x comma y varies with the g of x comma y. That means transform of f of x y to g of x y. So r is transformed to s. So how can you vary? So you can going to see one of the value, that is the linearly variation, is called identity. Now that means in this identity means nothing but f of x comma y, that is t of x comma y is equal to g of x comma y. No changes at all. So same, that is characteristics will show here. So like that, for this one reverse means is simple minus only, that is negative. Negative. So we are going to be understand these characteristics in detail, how these graphs are attained. That we are going to have one function with another of explanation. That we are going to have. See here, first I am going to be start one of the function of your intensity transform function, which I called as linear transformation functions, named as piecewise. What is that? Piecewise linear transformation function. Here, these piecewise linear functions can be arbitrarily complex. Why in this sense? A disadvantage is that their specific requirement significant user point from input to image. Input to image. So how this input image will be, the more we are going to concentrate here as arbitrary complex piecewise functions, So in terms of, let we take some of the example functions. Number one, this completely significant of this specifications which we want to concentrate in terms of example functions are: number one, contrast stretching; number two, intensity level slicing; number three, bit plane slicing. So today, this image processing of intensity transformation functions, which we want to concentrate in terms of piecewise linear intensity transformation, is more important. Why it is more important? Let we are going to see with other slides. See here, more important in the sense, you are taking your image. You are taking your image. In this image, okay, so from there, the content of the image information which is varying from one part to the other part. This is first part, okay, this is second part, okay, this is third part. How it varies one part with another part means the contrast stretching parts. These are the contrast stretching. How it may be varies this we are going to be understand this. What part is identity part? What part is exponentially decreases? What part is it is showing in terms of order of intensity levels that preventing the creation of intensity artifacts. So that means you are going to be understand part to one part to the another part reason wise. Let me to choose one reason to another reason. There are three reasons I've been separated. The first reason is here, which is r axis is x axis, r value is x axis, y value is y axis is s value. Okay, so here r1 equal to s1, okay, r2 equal to s2. What do you mean that? Your values are various here in between this part, first part. Values are varying, same. You see, as it is same. Doesn't changes in terms of complex. It is as it is. That's what it is called as identity intensity transformation process. That part is that process. Next, we'll go to the second part, that is this part. That is this part. What is this part? You see, R1 equal to R2, that is changes. So S1 will become 0. It's not changes. It is initially it is there here only, not growing. Next, S2 will become L minus 1. This is what your value is this. So that means here your value, how you may going to keep to understand this in terms of thresholding function value only. You are going to be choose that depending upon your domain knowledge of the image processing in a particular image which you are going to use for the particular application. There you are going to fix this threshold function. Then only this part, second part will be very easy for transforming of your. What is the T of R? R is what? F of x comma y. What will be become this T of R? Is S. What is the S? Your output intensity values varies in terms of g of x comma y. We are going to have a third point. What is third point is? Third part is this. That is what we are understood. Okay, that is in general R1 should be less than or equal to R2 and S1 is automatically will become less than or equal to S2 because this condition is at the input intensities. Then automatically output will also will become same. He is assumed that this function is a single valid and monotonically increases. See here, monotonically increases. Sudden, how it is? Sudden changes. From here to here, sudden changes. Okay, so this is x-axis, this is y-axis. See here, your r value, here s value. How it is? Not be going straight. It is sudden straight changes. So that is what we want to understand from here. So we are going to see this creation with little bit image stretched applications. I have taken here one of the image which is referred from this textbooks. Okay, so this textbook is one of the important textbook which we are referring either from either second edition or third edition of the book. Okay, so from there what we understanding is here the author explaining from the textbook by taking these two images. Okay, so what you will be understand from these two images, contrast stretched part which we are going to understand from here. You see, this one is before contrast enhancement. Okay, you want to increase this part. See, it's little bit not linear. If it is made to linear, it is a linear means this is a linear. So what part is not covered? This part is, two parts are not covered. So these two parts you are going to be concentrated to make your unity of the intensity transformation. So when you are going to make, then automatically your image will be enhanced. See here nothing will be visible, but where here we can see that what the image will be content. So this is the first piecewise linear process. Linear means identity process, as it is we are expecting. Coming to the this intensity level slicing means if you take your what is that internal part of the body which we are going to be see in detail. Certain time this part of the information which we want to going to understand, especially same from the same textbook I'm taking from chapter 3, okay, for this explanation. So here what they're explaining is here original image courtesy of Dr. Thomas R. Guest, University of Michigan Medical School. They've taken this image and processes in terms of intensities level slicing. Okay, so what is a slicing here? Slicing means you are going to be see each and every part. See, I don't want this alone. I don't want this. I don't want this. I want only this image. Only this image. So I can concentrate, no problem. So if you wanted to stretch much more, okay, in terms of slice means one by another, you can understand. You see here, intensity levels, how can we increase? That is, for example, same image I am taking from textbook, not from medical school. So here, original image is this. By applying my piecewise linear intensity transformation, what I got? Contrast stretching. By contrast stretching, I got this. Output image by thresholding. That means depends upon your domain knowledge. Domain knowledge, you are going to be keeping your threshold value. You are going to be keep your threshold value. So based on your threshold value, you are converting your image into much more intensity levels. So that's what we can understand from this figure to from this each one. Similarly, you wanted to see in terms of gray level slicing also. That means you take, for example, this is the one of the original image. This is one of the original image. Okay, one of the original image. From this image, you see your S values will be varying there. See, this is S value, right? Y axis. This is X axis is R value. Okay. So this R value, this is S value. Okay. So what we want to understand is that is S will become T of R. S will become T of R. What do you mean that? That means you are going to be understand that S is becoming as T of R. E is here towards to process from one level to another. One level to another. How it may be changes from 0 to A to B and the level. So these levels we can understand in terms of gray level slicing. See, for example, bit plane slicing is also applying right now. Even one of my students is concentrated on this for implementing the bit plane slicing for the sake of identification of fake current node with the original node. So the difference we can find. How can you find that? We can find each and every intensity process. Each and every intensity. So you are taking that processes here. So 3 images, we are going to be see that image reconstructed from bit planes. Okay. So how we are going to be vary that number of pixels levels, we can understand one to another. Which one is clear? Some more clear. So like that, we are going to be understand from here. Still, I want to give the more clarity on bit plane slicing, which is we are using 100%. It depends upon your intensity transformation functions concept. So what is that is here. Do you see how these layers are varying in terms of plane wise from 0 to 7. How it may be varying, you see. So 8-bit byte of data, because we are processing this in terms of digital image processing. Okay, so how can you are going to process? How can you going to be process this? Yes, we are going to be see each and every level of images, and we are converting what at bit 1 level how it is, bit level 0 how it is, bit level 3 how it is, bit level 6 how it is. Okay, because this is 3-bit level, in the sense you are increasing each and every digital values. You are checking each and every instant of digital values of variations. Sorry. So this is the one of the enhancing features in satellite imagery, such as masses. You see here, at present, the specific ranges of intensities are being highlighted in terms of intensity level slicing process also. So that's what the intensity transformations are very important. Okay. So coming to the second function, the intensity transformation of the second function is log transformation. Okay, logarithmic transformation is here. We are applying very simple in relationship with the s of r. What is r here? R is nothing but f of x comma y. What is s? Your s is nothing but g of x comma y. What will be the relationship now? G with f of x comma y. So it is very simple to understand in terms of logarithm. The minor changes of your logarithmic transformation we can understand from this figure. See how much minor you see here. Is there any possibility to get that 100% visibility is here? No. Okay, so that Fourier spectrum process, how can you understand is here, that is logarithm transformation of Fourier spectrum is right now applicable in terms of your changes. So which now you can understand this is your image and which is f of x comma y. Let assume f of x comma y and this is your original image. From this original image, now you are converting into g of x comma y by using your logarithm. See. And now from this, we are going to understand that logarithmic transformation of Fourier spectrum process is here. It going to be applied not in terms of negative. It is in the past. That is r plus 1. Okay. So next we are going to be use another what we call power law transformations. What do you mean power law transformation is here? That is a very simple this transformation function which can we understand in between s and r. In between s and r. So by the help of constant factor c and the gamma ratio. So this c and gamma both are the parameters which we call as a rate that is optimal parameter or we also called as rating parameter of the transformations. So that power law, that is gamma, will be defined at what gamma value you are going to be achieve your requirement of the intensity transformation. How can you define that? It is 100%. We are going to be define that gamma and the c values based on your domain process. That is your spatial domain process. That's what we started to understand this intensity transformation from the spatial domain process only. So from that knowledge, we are going to be define this C and gamma, and then we are going to be use your power law transformation. Got it? So this power law transformation, obviously, this all values. See, for example, that values by trial and error, if you assume being your students, right? We are learning some knowledge, right? So your starter learning from this teaching, So while you are learning, how can you get a confident level? Means which characteristics help you perfect intensity transformation happen in the sense. Let you start one by another. Value. This is what is showing. It is a final value. Suppose your gamma value is very, very, very minute value. That means your relation will be very exponentially increased. How it may be linearly settled by taking little bit time. X is increases, but y will be constant. How it is y is varying in terms of at a x constant value. So at a certain level only it is common. After that it is constant. What is constant? Here y. What is the varying here? X. What is mean by y? Is s. What is mean by x? Is r. We discussed already that is the difference between R and S. So try to understand this. The intensity transformation function which we are using here, S is equal to C into R power gamma. This function is called power law intensity transformation function. So only depends upon gamma. This is constant. You may fix that. You may be assume. Let us assume C is equal to 1, or it may be assume in between 0 to 1 some values, more minor values. Then you'll be start to get your required expectation. So these characteristics, which characteristics is more suitable for your application, is depends upon your domain knowledge of the image processing. Okay. So next, coming to the such a knowledge which we are using, your S is equal to C into R power gamma value, where this R is nothing but f of x comma y. What is f of x comma y? Your function f of x comma y. What is this f of x comma y? This is x, this is y. And now from this you are going to be change your gamma value, that is gamma correction application process. So another name of this power law intensity transformation is also called as gamma correction intensity level transformation applications. So you can cover here. So see here something like this application, especially this application is we are going to be take in terms of disaster management. In terms of disaster management, the disaster management application process is very important due to tsunami, due to cyclone. Okay, some of the part of areas may be affected. Before tsunami, how it is that place. After tsunami, after affected tsunami place, how it may be. We may want to analyze. You can use this gamma correction intensity level transformation process. So from there you can see, from this figure you see more visible. You see you can find out more. So that is what we want to understand. Here aerial image is this A bit. B bit means this is B. That is a resultant of applying transformation which is C equal to 1. That's what I said. This C will become 1. And gamma will be going to be vary. This gamma will going to be vary in between 0 to 1 or 0 to whatever your required value. That is previously we have gone through here. Okay. So that values of the gamma are vary, but C will be fixed. But depending upon gamma corrections, we'll get your required images. That is the important concept which we want to understand from here. Next, coming to the continuation of this gamma correction, gamma based intensity transformation is by taking one flower image, okay, one to another. This is we may going to say in terms of digital image processing. So being it is a grayscale image interpretation, okay. So that sequence how it may be varying is pixel to pixel how it may be varying. So your taking images are like this. This is 128 by 28. This is 64 by 64. This is 32 by 32 pixels. One another. You are compared to one another ranges of pixels values. And you are going to be understand that top row image is zoomed from one to another. Then we maybe see that how transformation happens. So coming to the application, so far we discussed these three major functions of intensity transformations are, okay, how these three are be vary. Piecewise-linear, how it may be vary. In terms of logarithmic, how it may be vary. In terms of gamma correction intensity transformation, how it may be vary. For example, you take medical image. Okay, how it may be. We have discussed here. We are taking a medical image processing. Okay, so especially this gamma changes values morely used here. Quality control system. Here we are going to be check with the help of second intensity level transformation function. That is what is second one. The second one which we are taking here is logarithmic. So we are going to use that. So next surveillance is bitwise. Bitwise bitwise slicing process. Here is a surveillance application process and law enforcement also we can go to use. The artistic effects we are going to use again gamma based, or we may going to use linear. What do you mean linear? What is the function of linear function which we are using? Very simple function. That is, you are going to be equating the f of x comma y to the g of x comma y. So by the assumptions, by the transforming your intensity levels from original image to your required transformation of the image. So with this, I wanted to conclude today topic, that is intensity transformation functions, how we may be used for your image processing will be understood not only from our lecture, my lecture. You can also refer these two textbooks. Basically, I referred this. Some of you maybe have gone through while we are discussing also. Okay, I'm really very thankful to your patient listen. If anything, you are required much more information on regarding this intensity level transformation. So that means the relationship in between f of x comma y to g of x comma y. How we are going to understand that relation only with these three types of intensity level transformation functions only. I'm very well thankful to you one and all, really, and thank you. I'm stopping right now. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.